Hello everyone, this is Eric from Iowa Robot Fighting. We are just now closing on our first competition as a group. Originally we had talked about there being about 4 members. Right now we only have 2, myself and our other member named Evan. We have been working on our robot designs for quite a while, and I personally have been developing my robot for about a year and 6 months, and Evan has spent about a month on his design and essentially 2 weeks building it. And I'll get to where the 2 designs differ here in a little bit. But the competition we're going to is up in Minneapolis, Minnesota, and we will be traveling to that. By the time this video rolls out, it will be tomorrow for you guys. The Minneapolis competition is going to involve fairy weight and ant weight combat. So for those of you who are not familiar with those weight classes, fairy weight is 150 grams, and ant weight, which is our category, is 1 pound. So considerable weight difference, a lot more hitting power. We are also considering doing beetle weight in the future, and in fact, I believe it's called sportsman weight is the 30-pound competition, and that's probably going to be a next year thing. So if you've seen our page, you'll have noticed that my robot, Cowboy Beep Boop, which is an exercise in why you don't let the internet name your robot, has gone through relatively significant changes over the past year and a half. To illustrate, this hourglass shape was the original design, and you'll see on some of our social media that this was what I was originally talking about, and was drawn up on our whiteboard. This is where I ended, and let me go through some of the reasons why that is. So anyone who knows anything about horizontal spinner robots will see the inherent flaw in this design. Any sort of spinning blade which hits low or high will end up being channeled directly in between these 2 ridges to split the bot in twain, as it were. So I determined that this was a bad call. So I moved to a low angle wedge. So the idea was that a horizontal spinner would be deflected. Most vertical spinners would also either not make contact or be deflected. And then a weapon bar could be placed here at a low angle to be able to impact others. However, as you'll see in the footage, there is a significant issue with having so much weight up front versus having it centered between the wheels. It was causing it to rotate around a central axis which was not between the wheels, as you can see in the footage. After that, I moved to what would become the essence of the design. So this is Cowboy Zero. This is the progenitor to the final design. So this had the wheels to be built within armor, but as I was constructing it, I noticed that this channel was too narrow. And what actually is happening there, if I can grab a battery quick. What's actually happening is I built this with the concept of a battery perfectly fitting in between. The problem was I needed to fit a safety switch in. Because of that, the battery ended up at an odd angle, and so did everything else. Plus, I didn't take into account the amount of wiring that would be put into this design, making it so difficult to jam anything more into this chassis that I realized that it needed to be elongated a little bit. Thus, Cowboy 1 was born. So Cowboy 1 looks almost identical to Cowboy 0. except for the design of where the weapon was actually sitting for the wires being fed through, and a few other length things. I widened the front a little bit, lowered the profile a little bit, and generally made some ease of use changes. Cowboy 3 is a finished chassis. So the problem that I had between Cowboy 1 and the rest of my setup was not design, it was print. So as you can tell, this is all 3D printed. The problem I had was the supports that were being put in place to get these holes where I needed them ended up causing sections to split. And whether this will affect the overall design in the future, in the competition, I don't know. But as you can see, that is where the final design comes from for Cowboy Beep Boop. So with the assembly of Cowboy Beep Boop, it all has to be in a very particular order based on how the design was put together. Weapon motor has to go in first. Without the weapon motor's wires being set up just right and it being screwed in correctly in the bottom, there tends to be a series of issues trying to get those wires in. As a weight saving measure, I also decided to do everything in series for assembly when it came to the wheels. Drive motors have to be put in first, and then the wheel hubs with wheels already in place need to be on the drive motors. Then the outer armor can be put onto the robot. And it has to be done in that order. If there's any damage to the wheels themselves or the motor, that all has to be torn down, and even the top plate has to be removed in order to get access to it. So it's almost a complete teardown, but the design lends itself to being very open, and based on the timing that I've done, it takes at maximum, when I'm taking my time with it, about 15 minutes to do a full rebuild from scratch if needed. So this brings us to the weapons themselves. If you've seen any of our previous videos, the weapons have gone through a series of tests for us to be able to determine what speed of motor is required, what battery, all sorts of different things. We started off with a really cheaply made, and lack of a better term, shitty motor that we actually burned out a couple of in testing before we landed on going with brushless motors like everyone else does, which are typically used for airplane propellers. But the process involved required that we come up with a variety of pieces of equipment to ensure not only our safety, but proper testing. One of those pieces of equipment was our little cart here, which is used inside the test box in connection with some 3D printed blocks, which could be driven into our weapon that was being spun up. You can tell they served their purpose relatively well. We ensured that we were able to test motor mounts and figure out how strong things needed to be. But one of the problems we encountered was the fact that we were securing the weapon to the box floor, which meant it was trying, rather than a 1 pound object hitting another 1 pound object, which this is weighted for, and the robot should be, it was a 1 pound object technically hitting an infinitely weighted object. So something had to give because it was hitting something it was already connected to. So it didn't quite work. So that solution came in the form of creating a separate chassis. And you might notice some similarities here between the weapon test block design and Cowboy itself. It's the internal mounting for the weapon. First of all, I needed to find a way to weight the block to ensure that it was 1 pound. Also, I needed to make sure that it was going to stay upright, not destroy itself, all sorts of things like that. After running this test, I determined that where I was setting up my weapon was going to be too tall to impact anything less than 1.5 inch tall robot, which doesn't quite work in the grand scheme, because most robots are going to be as low profile as possible. Thus the design of a sloped mounting point, so that the motor is then treated to a gentle grade to bring the weapon to bear at a lower angle. This allows me to strike low profile robots and ensure that I'm not whiffing over top of them. At the very least, I'm guaranteed to hit their tires. But that wasn't the end of weapon testing. We needed to know whether or not a sharpened edge was going to be beneficial. After a series of tests, we determined that you could flat out lop one of these in half, but that's unarmored, and you were going with the print lines. We then tested with a piece of aluminum around that. We determined that the blunt object was able to dent in and send it flying, or at least not get wedged. But one of the things we did determine that is if you had a beveled edge, a sharpened edge, it would potentially get lodged in the armor. If it gets lodged in the armor, you just bound the two robots together. Not exactly ideal when you're attempting to win a fight rather than having to pause it continuously to unstick the robots. So we decided to scrap the idea of our little garbage disposal blade, which is not what it is, but that's what it reminded us of, and roll with something more akin to what you'd see in BattleBots. Ironically, we should have assumed that the BattleBot drivers and designers had a reason for using blunt weapons, but we wanted to test it for ourselves. So as I said in the early part of this video, I kind of went overboard when it came to the mass production of components, not the least of which are the sheer number of chassis that I put together in an attempt to ensure that if I took massive damage, I was always able to bring the robot back up to snuff. And that comes in the form of actually having 5 full chassis ready to go, 2 complete robots, and 5 chassis altogether, including the complete robots. I didn't stop there though. I know that wheels can be quite expensive, not to mention time-consuming to deal with. The FingerTech robotics wheels that a lot of people rely on are simply foam rubber with an aluminum hub. They're difficult to put on, they require a special tool, and are very, very expensive for what they are. I decided to remedy this situation for myself and my team. So I went about the process of designing a custom 3D printed hub that's not only able to be taken on and off without removing the tire itself, but I put together a whole series of wheels that are complementary to it. To do so, I utilized a specialty jig. This jig allows me to cut wheels of multiple different lengths, I should say multiple different radii, and allows us to adjust the ride height depending on situation. The cost reduction is significant. We're paying less than 5% of the overall cost due to 3D printing and using a set of rolled foam rubber to cut blanks, drill those blanks out using a drill press, then using the jig, cutting the wheels to the radius that's required, and then simply mounting the wheels to the hub using a couple of screws and a nut and a screw on the back instead of a typical set screw. Wheels aside, there is also the matter of armor. Now this is custom to every robot, but as you can tell, I have aluminum plating on all but the back. That aluminum plating was all cut and formed by me. And then we have polycarbonate top armor, which most people use for their robots. However, because my robot is a 3D print design, I decided that I would 3D print out tracing templates to ensure that I got the bends at the right spot. The sizes were always standardized, so it didn't matter which chassis I was dealing with, I would always get proper fittings all across the board. The last item is the safety switch. Now, almost every competition requires a safety switch of this type to be some sort of Allen screw to be able to cut off power so that you can't accidentally power on your robot. It also ensures that it's not a rocker switch with the capability of being turned off mid-fight without the destruction of the switch itself or the cables connected to it. This took a lot of time to work out, but it is kind of based on the FingerTech design. However, most are. I'm pretty positive the FingerTech design was ripped off by some other group. So it's simply two pieces of copper inside two plastic shells, which are then super glued together, and a screw is run through them after cutting a series of holes in them with the drill press and soldering them together. All it does is cut the circuit between the battery and a three-way connector, which is required for feeding power to all three electronic speed controls inside the robot. As with most of the robotics in this class, there's quite a lot of modification that ends up needing to be done on the components just to make them suit your needs. Anything from the cutting off of an on switch so that you don't have several on switches inside and soldering it, to needing to solder connections onto your drive motors. That's all super simple stuff that ends up being very important, to one of the more interesting modifications that I needed to make, which was the actual cutting using a die to add threads to the weapon drive motors. With the need for being able to attach the weapon without raising the height, I needed to find a way to cut down on that. The fastest way to do that was to thread the drive shaft. Then, utilizing a couple of nylon thread lock nuts, we are then able to lock the weapon in the exact height that we require for the robot itself. This gives us the capability of ensuring a strong connection without any 3D printing or extra aluminum parts that other robots have required in the past. Some modifications work well, others don't. Sometimes we end up with electrical shorts, which you can see right here, where there was a three-way connector that was poorly implemented and ended up shorting itself out and then burned out a safety switch in the process. Luckily, it didn't burn out any of our other electronics. It simply smoked out the interior of the robot. Me being me, of course, I didn't realize what was shorting out and then thought it was the safety switch. So I hooked in another safety switch, and of course that one smoked out too. Then I realized it was shorting out farther down the line. Replaced that, got it working just fine, no matter how irritating that might be. So I'd be remiss in my duty if I didn't talk about my teammate's robot as well. So Horns of Jericho, which is Evan's robot, went through a really quick design process. Evan started late. He had every intention of starting as far back as I did, but He is not well versed in CAD software, nor did he have the inkling to actually learn the process of designing things in CAD. So we decided that we would rough out a concept in foam core, hot glue it together, and then use that concept to design the overall chassis. We originally had the plan to use polycarb and a type of epoxy called plastic bond. As it turned out, the plastic bond was not strong enough to hold the polycarb together. In fact, it bonded very poorly. And that being the case, it ended up splitting apart. Every time my robot hit it at all inside the test box, it would just shatter. We did see some promise with the actual concept of the robot, but we had every intention of going and saying screw it and wrapping it in duct tape, essentially, just to hold it together long enough to withstand a fight. The problem came, the last straw came, when we realized that spinning up the weapon caused a deflection and a resonance in the front of the robot, causing the weapon bar, which is kind of simulated here on his finished product by this disc. It ended up deflecting and making contact with the front of the robot, shattering the front of the robot. So we, a matter of a few days ago, scrapped the entire concept and moved to a bent aluminum chassis with acrylic to support the weapon mounting region and a polycarb top plate screwed in, and thus the Horns of Jericho were born. Plenty of space. I actually had to custom design some wheels for him to be able to run upside down as a top cutter or an undercutter. And with it being able to run upside down like this, he has plenty of opportunity to strike with this. He actually has a very large weapon, which you will see in some of the combat footage that we'll have for this robot sometime in the next, probably in the next week. So we decided we needed to practice quite a lot. Neither one of us has done any sort of combat robotics. I personally have flown RC planes for quite a long time. I, at one point in my life during high school and early college, I competed in RC racing competitions, but neither one of us had controlled a combat robot besides the little tests that I had done with the Prime robots early on in this endeavor. Evan, however, only had a handful of minutes in controlling any sort of RC car or anything to that effect. So we decided that we would utilize some time in a test box of our creation. Beyond the weapon test box, I created a small arena that could be put on the floor for us to be able to get used to sparring together. Thus the reason for this disc. This disc is our blunt weapon. It's for sparring with the robots. Any other time we would be running, obviously, a weapon bar, which has significant hitting potential, as you can see. But that isn't ideal when we want to conserve parts. So we had a few sparring opportunities to be able to test our own skills and get used to our robots. Now, do I think that gives us an edge? I don't know. I don't know how much other competitors have had an opportunity to run their robots up against someone else without destroying them. The problem comes in that our weapons aren't actually doing any damage, so we don't know what sort of reaction a weapon-to-weapon strike is going to have, how much damage our robots are actually going to take. The plan was originally, prior to this competition, to get in and actually sacrifice a chassis apiece to having an actual match. That wasn't possible. We ran out of time. Evan's robot wasn't able to be put together until just a couple of days ago. So we're down to the wire. However, this first competition is going to be very instructive. I have really high hopes that we're going to do well. At least not make fools of ourselves at a local competition. Because I'd really like to move on to 3-pounders and 30-pounders in the near future. If I don't go through all my components that I've crafted, I have a feeling we have a good shot at going to multiple competitions in the beginning of next year, possibly one more this year. I don't have much faith that we'll be able to find one that's suitable for us, though. All that being said, we appreciate all your support on our social media, and we will be bringing more videos just like this in the near future. If there's something you'd like us to go deeper into about our process, our robots, or anything that you've seen in our videos or social media posts, don't hesitate to bring it up. We want to cater to anything that you guys want this channel to be, because we're not even sure what this channel can be yet. We know we want to go into showing you what the 1 pound, 3 pound, and 30 pound process is like, what the fights are like for rookies like us, and our breakdowns and reviews of what we think went wrong at any given event. Everyone have a great day. Tune in next week to see the fights and possibly a review. We're more than likely just going to post up some raw footage or some minor cuts of what happened at the event, and the following week we will likely be posting up some reviews of how we think we did, what could be improved, and what we might do next time for preparation. Thanks again for watching Iowa Robot Fighting. My name is Eric. Everyone have a great day.